want to discuss this result that came out in numberphile about the cross ratio. It was covered by mathematician Federico Ardila, and there he speaks about a soccer field and a certain distance from a goal, and one wanting to find the distance from that goal using a picture. Now, here's the thing. Something that I didn't see covered there explained, and it's something that is worthwhile to see in a picture all at once is the following. The cross ratio theorem, it says this, right, that if you have four lines that cross at a point, and you have any line that crosses them like this so as to make these distances, right, uh, like this, that this ratio, let me see where I put that in here, this ratio, um, like this right here, that ratio right there is preserved. So in other words, if you take this piece right here, the sum of these two, times the sum of these two, divided by this whole thing times this, that is constant. So in other words, had you made another line cutting like this, and you look at those distances, and you make those ratios of those distances in that same way, that that quantity does not change. All right. So now let's see how it relates here. So here you have, let's say, a plane. You have a line on that plane with 4 points on it. And then right here, you have a point that could be seen as a pinhole. So that's, let's say, the pinhole of a pinhole camera. Then this right here, this back thing right here, is the film of the camera, right? Okay. So the images of these points right here are these points back here. But since the angle that the back of the camera makes, right, it's not the same thing as this one, etc. Right? Those distances between those four lines and that retina or that line back there are not the same thing as these. However, the cross ratio between the two will be the same. Okay. Now, why would that cross ratio be the same? Before I had done the theorem, but with one line here and another line here, right? Well, the thing is this, that if you have a point here and you have a distances right here like this between lines, well, if you have take a parallel line on here, on the other side, you can see that these distances will be the same. So in other words, whether it be like basically, if you take a line parallel to this one and at the same distance from here, to here, like that, you cut through here, then these distances right here, the corresponding ones will be the same thing as these. Okay, so now knowing that, you know that you can use the cross ratio theorem on this setup, and compute the cross ratio on this right here, and this line right here is that basically the picture image. Okay, so now in his problem, here's what he had. He had a certain let's see if I see here. I changed the letters a little bit, but anyways, he had an actual soccer field, and then this right here was the distance from the ball to one marker line that he knows the specific name of those boxes, but I don't play soccer, so I don't know these. But anyways, he had the ball. He had one of these markers. Then you had the other marker right here. So he wanted that. Except that somehow in the picture, what the line that he chose was really the one that corresponded to this line right here. Okay. Now, so I call these alpha, beta, and gamma. These distances right here, alpha, beta. This one right here, and gamma. And this one right here, A, B, C. Now, by let me see, where did I write that? Somewhere around. Oh yeah. So let me show you what is known and unknown. So the alpha right here, alpha is unknown. That's the distance from the ball to the beginning of that marker line right here to go. And let's see. Okay, beta and gamma, these distances right here, they are known. Okay. Now, see where did I put that here right now? Okay, so by basic triangle similarity, it turns out that A equals K alpha, B equals K beta, and C equals K gamma. That's right here. See? This guy right here is K alpha, this guy right here is K beta, and this C right here is K gamma for some constant K. All right. So now we're back to the situation. So you have these three things, which are these right here, that is lowercase a, lowercase b, lowercase c, lowercase a, lowercase b, and you have these up here, upper the corresponding ones, uppercase C, uppercase B, and uppercase A up here. So what do we know about the cross ratio? Well, it's right here. That this quantity right here, which is the cross ratio for this thing right here, for the camera part, that's equal to the cross ratio for this thing right here, right? Or, this thing right here. Okay, so we write that down. But then we know, since what we are actually know are the alpha and the beta, those other, like the straight line distance, the perpendicular distance, I just replace these guys by their corresponding alpha beta counterparts, and you see you have here a k, but it turns out that the k gets canceled, so you end up with this quantity right here. Now, given that alpha and beta are known constants, beta and gamma are known constants, alpha is the unknown and all this, right? What I'll do is this: I'll just rename alpha, I'll call it x, and beta, I'll just use beta, but then beta plus gamma, I'll call it capital M, so I won't have to write that much, and same down here, so we write that. Okay, here I said it right. Yeah, M is beta plus gamma, and alpha is equal to x. Okay, now afterwards, by the way, this guy right here, remember, these you measure these are the photograph quantities. So these you actually measure with a little ruler or whatever, and you have these photograph quantities. And at the end of the day, this is just one number when you combine it all, and that's what I'll call n. So then we have this equation that n is equal to x plus beta times m, beta x plus m down here. So then we just do algebra on this. So we have beta nx plus beta nm equals mx plus beta m. And then finally you get that x is equal to this. And since all these are numbers and they're known, you have your answer. So that's just a gloss on that numberphile episode, and that what I consider the most important thing that you could take away from this is this picture right here. See how the setup of the actual field right there, and then the camera right here in the pinhole. And the interesting thing is that you don't know at which angle the camera took the picture, but that doesn't matter. Any which way that it was taken, the ratio is preserved, and blah blah, and all the calculation works out.